Now we're going to learn how to write up this lab and how to answer the questions. I have written in the times from this empty cart, and I wanted to show you how to do this calculation as an example. First of all, we need to average the 3 times. So we type in 2.25 plus 2.52 plus 2.36, hit the equals button, then divide by the fact that we have 3 data points. So the average time is 2.38 seconds. Notice I've also written in the mass, the height, and the length of the ramp. First, we're going to calculate velocity. Velocity is distance divided by time. So the distance or the length is 1 divided by the time of 2.38. That gives you a velocity of 0.42 meters per second. I would keep at least 2 decimals here. When we calculate kinetic energy, you can look on your reference table, and kinetic energy is 1/2 mv squared. So on your calculator, type 0.5 for a half times your mass, 0.140, times your velocity, 0.42 squared. And this will give you a kinetic energy of 0.012 joules. I would keep at least 3 decimal places. Finally, calculate your potential energy. Potential energy is also on your reference table, and it's mgh. M is the mass, g is the acceleration due to gravity, which is listed on your reference table as 9.8 meters per second squared. Then you'll need the height. So the mass is 0.140 times gravity, or acceleration due to gravity, 9.8, times the height, not the length, the height, 0.0685. That will give you a potential energy of 0.094 joules. Once again, keep 3 decimal places. You can now do the rest of your calculations the same way. Let's take a look at the questions. Which cart had the greatest kinetic energy, the heavy or the light cart? Look at your data and figure out which one had the greatest kinetic energy. Explain why it had the greatest kinetic energy. Well, kinetic energy is 1/2 mv squared. A greater mass will give you greater kinetic energy, and a greater velocity or speed will give you a greater kinetic energy. The heavier cart had the heavier mass. So just explain that here. Which ramp height had the greatest kinetic energy? Well, the taller ramp has a greater velocity, and the less steep ramp has a lower velocity. So the greater velocity will give you greater kinetic energy. So explain that the steeper ramp gives you a greater velocity, which will cause a greater kinetic energy. That explanation will go here. Number 5, which ramp and cart combination started with the greatest potential energy? Of course, you only have the potential energy at the top of the ramp, not at the bottom, so that's what it meant by that. Look at your paper and tell. Did this combination result in the greatest kinetic energy? Yes or no? If it did, great. You can skip question number 7. But if it did not, what happened? A few years ago when we did this lab and we only did each trial once, we got horrible data, and that usually caused the kinetic energy to be off. But once we started doing this lab 3 times for each experiment and averaging the data, we've actually got a lot better data since then. So you can skip number 7. Number 8, why are the kinetic energy and the potential energy not equal? Well, what messes up every machine? What always gets in the way? What slows down your cart as it goes down the ramp? Number 9, which had the greater effect on energy, mass or velocity? Once again, remember 1/2 mv squared. Well, the mass is just multiplied, but the velocity is multiplied and it's squared. So the velocity actually has a greater effect on kinetic energy. And the reason? Because it is squared.